Okay, now let's look at question 4. Question 4, um, it says the diagram below shows the graph of the function f of x is equal to b to the power of x plus c. Remember, we know that this kind of function, it is what? This is my exponential function. Okay. And g of x, it is equal to that one. I know this is my hyperbola. And then they tell me that b, which has coordinates of -6 and 0, it is the x-intercept of g. Let's confirm that. X-intercept of g here. And then the graph of f and g have a common y-intercept. Common y-intercept here at, I think it's negative, blah, blah, whatever. Then P is a point on F of those coordinates. P is a point on F. Where is F? Remember F, it is this graph, guys. So P is a point on F. Leona. Okay, fine. So let's try to answer the questions. Write down the value of P and Q. Now let's analyze. Remember P and Q are what? When we look at our thing here, P and Q are our asymptotes again. So we need to look at the asymptotes of the what? Of the hyperbola, guys. Very straightforward. Hyperbola has an asymptote here at x is equal to 2 and y it is equal to -1. So it means the value of P. So it means the value of P is going to be, okay, guys, let me just finish with Q. Q is going to be, remember Q, it is the y. Q is going to be -1. But when we go to P, guys, here is a catch. X plus P should give us what? Should give us 0. And now we know that here x it is equal to -2. And then we know that y it is equal to -1. But I know that q it is equal to y, which is equal to just -1. Okay. But in this case, x plus p, when I equate it to 0, I should get x it is equal to negative p. But now, even if I don't even need to do that, I need to substitute this -2 where? Here, and say -2 it is equal to plus p it is equal to 0, and then p will be equal to 2. So p is not -2, but rather p it is equal to 2. And then q is equal to -1. Guys, let me just make sure that you understand this. Remember when they want you, when you are given a, let me say 3x plus -2 plus 4. When they say give the equation of the give the equation of the asymptotes, you're gonna say x is equal to, if this is negative here, you're gonna say +2, and y it is equal to 4. Okay, can you see? Remember, this is the same as x minus p plus q. So can you see that p, when it is minus on the formula, when you go to the x is equal to something on the axis of on the equation of the asymptote is going to be positive. So it means here, since well here x is negative here, on the graph is going to be positive. Hence, I'm saying p is supposed to be positive. Okay. And remember what we find, that we say x minus 2 it is equal to 0, and then x is equal to 2. This is the equation of the asymptote, and then y is equal to 4. This one is the straightforward one. Hopefully it is clear, guys. Yeah, hopefully it's clear, guys. Hopefully. And then determine the equation of g. What is g? Oh, g is that hyperbola. But we already know that we have g of x to be equal to, we already know the value of a. I'm lying. We already know the value of p is going to be x plus 2 minus 1. And then we need any point that lie on that graph of we need any point that lie on the graph of g. This is the graph of g, guys. Hyperbola. So I can take b. I'm going to sub b. When I sub, what's going to happen? I'm going to be left with, I'm going to say y is 0, and then a into x, it is -6 plus 2 minus 1, and then you solve for a. This is going to, okay, let me do this. 1 is going to be a divided by -4, and then your a will be equal to -4. And then the equation of your graph is going to be therefore g of x, it is equal to -4 divided by x plus 2 minus 1. Okay, yes. And now the value of a should be negative because we drew our graph on quadrant number 2 and 4. So quadrant 2 and 4 means a is negative. So this is your equation, guys. And then they say determine the equation of the inverse of the axis of symmetry of G for m is less than 0. So let's first find the equation of the axis of symmetry that has, remember, m is less than 0, meaning the gradient that has a negative gradient. Okay, so let's go to our graph. Remember, the axis of symmetry will pass through this point, the point of contact, which is x is -2, y is equal to -1. So our axis of symmetry, the first one with a positive gradient, will pass there. Like that. And remember, the gradient is always 1. So with the positive gradient, it is x plus c. And then with the negative gradient, it's going to pass there also. Okay. But now it has an equation of -x plus c. So there are two methods that you can use. The first one, it is to use this one, where you say, let me substitute the point of contact, which is what? -2 and -1. So it's going to be -1 is equal to x. X is -2 plus c, and then c is equal to 1. Therefore, y is equal to x plus 1. Okay. The second one that you can use is come here and say, guys, I don't need this one. I need the one with the negative gradient. So how about that? So I'm going to say y is equal to -1 is equal to -2 plus c, and then c is equal to -1. Therefore, y is equal to am I lying, guys? I'm lying then. -3. Therefore, x is equal to -x minus 3. This is the equation of the axis of symmetry with a negative gradient. Or what you can do, you can come here to this equation, take this thing there off. How do I take this thing and use it? I'm going to say the one with the negative gradient, I'm going to just say negative, and then the one x plus 2, put it inside the bracket, and then -1. Then you'll see that it is -x minus 2 minus 1, which is just -3. Can you see now the equations that I've rewritten here are the same, -x minus 3. So yes, guys. And then what you're going to do is that, remember, you don't want the equation of that one, but rather you want the what? The equation of the inverse of the axis of symmetry. So you need the inverse of this one. So how do I find the inverse? I need to swap x and y. When I swap x and y, it's going to be x is equal to -y. Guys, when I swap x and y, the sign will remain the same. And then I need to solve for y. When I take y to the other side, it's going to be -x. When I take it to the other side, and then -3. Guys, this is the same thing we're saying. But yeah, guys, we are getting the same thing, which is, yeah, it's correct, by the way. So these are easy marks for you getting this one, and then the equation swapping x and y, and yeah, just easy for marks, guys. Right? Write down the equation of the asymptote of f. Equation of asymptote of f. It is our exponential graph. So let's see. Our exponential graph goes like this again. So it has an asymptote at y is equal to -4. So it does not necessarily touch. Just that here it shows as if it touches, but it does not touch, guys. So the asymptote, it is y is equal to -4. Just easy. This is easy. And then they determine the equation of f. How do I find the equation of f? Remember, f of x, we are given to be something like b to the power of x plus Q. But we already know that Q, it is which Q, remember, it is our asymptote, which is -4. And then you just need to sub any point. So I'm going to sub point P because point P is a point on that graph, which is 2 and 5. I get 2 and 5. And then y is 5. And then e to the power of 2 minus 4. And then this is 1 is equal to b squared. And then, guys, I'm lying. 9. And then b is equal to plus or minus 3. Why, guys? You need to square both sides. When you square both sides, guys, you need to, even you know what? Apply laws of exponents. And then the equation can now be written as f of x, it is equal to 3 to the power of x minus 4. How do I know that this value is 3, not -3? Because the function is increasing, guys. Yeah, but yeah, it's just that. Determine the equation of h of x is equal to f of x plus 4. So this is easy, just the h of x. What is f of x? F of x, it is 3 to the power of x minus 4, and then you just add 4. So h of x is just 3 to the power of x. And then write down the equation, determine the equation of the inverse of f in the form of y. So if y, which is the 3 to the power of x, then the inverse is going to be y. Is going to be y is equal to log 3 to the power of x. I usually tell my students that you don't need to do the x and y, interchange x and y and what. For this one, you get 2 marks. For final answer, you get 2 marks. Because when you move from exponential to just a logarithm graph, you just need to add log and then write this thing as it is. But do not write it like this. Do not say log 3 to the power of x. No, you know it's log 3 base x, like that. But you can say, let's swap x and y. It's going to be x. It is equal to 3 to the power of y. And then when I want to solve for y, I need to drop it legally, log 3 to the power of x. Guys, I award you 2 marks for this one, but it's fine. For which values of x is f of x greater or equal to g of x? Let's check. Where is the graph of f above the graph of g? Let's highlight the graph of f first. So we have highlighted the graph of f. So where is it above the graph of g? Can you see that in this portion? In this portion, the graph of f, it is below here. Here, the graph of f is below the graph of g. So it is below, blah, 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 blah. But the minute we just cross the asymptote, can you see when, because this one is going to continue up there. So the minute you cross the asymptote, when you cross the asymptote in J, now f is now above. So it's going to be above until infinity. So it means the value of x where f of x is greater or equal to 0 is going to be x. I know it is included, so we're gonna x is an element of, but now I cannot include -2. I know it starts from -2, but why do I not include -2? Because at -2, the graph of g does not touch. It is an asymptote for the graph of g. So I need to exclude that because it does not touch the graph of g. So -2 to what? To infinity, but also I do not need to include infinity. You never include infinity. Or someone might say x needs to be greater than -2. Just 2 solutions meaning the same thing, just different intervals. So yeah, that's that. And then, yeah, it ends there, guys. It ends there. It ends there. This is the hyperbola and what. So let's move on to question 5, where we deal with parabola and whatever function they've given us.